We're going to look at the geometry problem today, and we have a triangle ABC where M is midpoint here, D is at the position such that the BD over DC ratio is 2/1. And we try to find the ratio of the length AO over OD, that is the median line here, CM. How does it cut the red line? Now, this is based on a basic property of geometry of a triangle. Now, we know that in a triangle, the area is base times height. If the area of ABC here would be base times height. Similarly, ABD is base. In this case, base would be BD, right, times height. And ADC here, if CD is base, then base times height, and divided by 2, that would be the area of triangle. We're going to heavily use this basic fact. In this case, we have a triangle, and we have a point here such that they have different base, A and B, for the smaller triangle on the left and on the right. So what is the area of the smaller triangle here with base A? Okay, so it's going to be the formula half base times height, where the height is marked here. Similarly, for the other triangle, let the area be T, and of course, as we mentioned earlier, is also half times base. In this case, would be B times H. When you do the ratio, the H would cancel. It's simply the ratio of the base. That's the basic fact. For example, in this diagram, I have a triangle here, the smaller triangle, with base A, and I have another with base B. It's important to understand that the base doesn't have to be horizontal, right? In this case, S over T ratio is going to be the ratio of the base, A over B. Another useful fact about the triangle and the fact that we learned today is the case for median lines. We all know that the 3 median lines of a triangle would meet at a common point, that is the centroid of the triangle, and it has a property that the centroid point cut the median lines with 2/1 ratio. All right, so as we marked here, in the case of triangle AMC, right, that's a triangle, by applying the fact that we learned earlier, the ratio of S over T would be 2/1, because the centroid here, M, cut the median line by 2/1 ratio here. Okay, that's another very useful fact. You may find it in the AMC exams. All right, now we have the foundation. This is all we need to know in order to solve our original problem here. All right, so we need to find AO over OD. Let's assume the ratio is X over 1. Imagine if the area of this tiny triangle is 1, then the other part would be X, because the ratio of the base is equal to the ratio of the area. All right, so that's what we're going to use. Of course, we need to find X. We're going to assume the other area here is Y and Z. All right, so we know that since M is a midpoint, and this triangle here, X plus Y, would equal the area Z plus 1. Notice that this value are the area of the triangle, right? Why that is the case? Because AM equal MB, right? So AM equal MB, we have the area X plus Y would equal Z plus 1. All right, here, Y plus Z is the pink triangle here. The ratio of that over X plus 1 is 2/1 ratio, because BD equal 2 of DC, right? The ratio here is just 2/1, right? So we know that Y plus Z is equal here. Now, we need to find X. We don't really care Y and Z, okay? What we can do is to make this connection here, the BO, yeah? And notice that we use the smaller triangle OBD, OBD versus ODC here, right? So this smaller triangle here. Notice that they share the height and the base ratio is still BD over DC. That's 2:1 ratio. So that is, this area is 1 and the other part must be 2. That is, the area of OBD must equal to 2. So that's 2 and the other would be, and Z minus 2 would be the remainder, right? So this, the add up to Z here. So here we would like to make adjustment that Z minus 2, the area of this triangle, and Y, they are actually equal to each other. Why that is the case? Because as we highlighted here, they share the same base and with same height, because M is the midpoint, AM equal MB, so we're going to know that Y, the area here, is going to equal Z minus 2. We're going to use that. Now with this new relation, we're able to cancel Y and Z in the first equation here, right? So Z equal Y plus 2, we're going to plug in to the first equation here, X plus Y equal 1 plus Z is Y plus 2. So we have Y plus 3, and Y would cancel, and X would be 3. That is the quantity we're looking for. That is A over D ratio is 3. Okay, so that's the answer. Now, for this problem, there may be other method using analytic geometry or other means, but I think personally this probably the simpler method is based on a very simple fact regarding the triangle. And the area ratio is equal to the base ratio of two triangles. That is all we need to solve the problem today. Hope you follow the steps, and in the meantime, please like, share, and subscribe to the channel.